Do you know how to find these numbers? So today I'm beginning pre-calculus lesson 3, which is radicals. So please keep on watching this video to learn how to find these numbers. Hello everyone, welcome back to Dona's Academy. Alright, so today I'm beginning pre-calculus lesson 3, which is radicals. So before watching this, you have to watch lesson 1 and 2 of this series if you haven't watched them before. So I have copied links to those videos in the description box, and also you can click the iCards shown in the top right corner of this video. Alright, so let's begin. Radicals. Okay, so what are radicals? Now, if you have this thing, let's say we have 2 to the power 3. What is this? This is 2 times 2 times 2, which is 8. Now, we see that the cubic power or the third power of 2 is 8. Now, if we go reverse operation, then we can say that 2 is the third root of 8. Because if you take the third power, we get 8. That means if you go back and if you think about the reverse operations, then that means 2 is the cube root. 2 is the, let's say, third root or cube root of 8. All right. And we denote this by this notation. We write 8 and we write square root type symbol. However, you have to put 3 here, a small 3 here to denote it, to denote the third root. And this is 2. This is equal to 2. We read this as cubic root of 8 or third root of 8 equals 2. All right. Okay, so this is one example for a radical. Now, which is my first example. Second one. What if I take 3 square? This means 3 times 3 equals 9, right? Now, we can say that 3 is the second root. We usually don't say second root. However, the standard is square root, right? Square root of 9. And if you use the symbols, we write 9 and then we use this symbol. It's not necessarily to put 2 here because sometimes we just use this symbol to denote the square root or the second root. And this is equal to 3. Now you have to understand that some people misunderstand this as plus or minus 3. It is completely wrong. Now you have to watch my square root video. I have explained that in detail in that square root video. You can click the iCard on the top right corner, or you can click the link I have copied in the description box. So please watch that video to understand the square root in detail. Okay. All right. Okay. So now we have talked about 2 examples for radicals. Now let me explain the general definition and general notations. So we use, we take a positive integer n here we assume that n is a positive integer bigger than 1, strictly bigger than 1. It can't be 1. We don't consider 1. We consider 2, 3, 4, and so on. Okay. And we take a positive, not necessarily positive, a real number, right? A real number. And then we use this notation to denote the nth root of a. Okay, this is called the nth root of a. All right, so this is the notation we use for radicals. Now you have to understand some terms. Now this is the symbol, and then my number a, and here. Then we call this whole thing. This whole thing is called radical. Okay, radical. Simply it means nth root of some number, right? And we call this inside number a radicand. Radicand. And the symbol before that, this n. This n is called the index. Index. And this symbol is called radical sign. Radical sign. All right, so here are some definition of the pieces of the radical. All right, now let's consider some properties. Properties of, not exactly properties, a couple of definitions of radicals. Now, here I consider a couple of cases. First one, if a is 0. If a is 0, then always this value, this value is always 0 for any n. It doesn't matter, we take even or odd integer. For any n greater than 1, right? It is 0. Second one, if a is greater than 0, that means positive, then this thing is always positive real number. It is a positive real number. Now, what does this mean? This means that if we take nth root, of a as b, then we know that b to the power n is a, right? This is the meaning. And b is going to be always positive real number if a is positive, okay, for whatever n. Example, an example. If you take third root of 8, then this is 2, right? Positive. 2 is positive. If you take second root of 4, it is 2. It is not plus or minus 2, right? So again, please watch the square root video if you are not sure about it. Okay, so again, it is positive. All right, next one. If a is negative. If a is negative, you have to be careful. you have to consider two cases. First one for n odd, second one for n even. All right. Okay, so when n is odd, then this thing is a negative number. It's negative real number, right? For example, if you take third root of -8, then this is -2. Why is that? Because if you take the cube third power of -2, then this is going to be -8. All right, so it is a negative number. All right. Next, the even case. In this case, this thing is not a real number, right? This is not a real number. In this case, we consider complex numbers. In future, I will do a video on that. Okay, so examples now. If you take second root of -9, it is not defined as a real number, because if you take this as b, right, then what is happening? According to the definition, b square should be -9. If b is a real number, a square of a real number is always positive, right? Always positive. So this is a contradiction. It can't be -9 because this is a negative number. So that's why we can't define them as real numbers, right? Not real. This is not real. All right. Okay, so we considered three definitions for radicals. First, three definitions means three cases, kind of, right? For any n, if a is 0, I mean the radicand is 0, then the radical is going to be 0 for any n. Second, if a is positive, the radical for any n is going to be positive real number. However, when it comes to the negative case, if a is negative, we have to consider two cases, an odd and an even case. In odd case, the radical is going to be negative for an odd, right? In even, it is not going to be a real number. We can't define it as a real number. So these are some very important cases you have to remember. All right, next, I will give you a note, kind of another definition or a term we are using, actually a name. When it comes to n equals 2 case and a greater than 0 case, because if a is negative, then when n is even, here 2 is even, then we can't define it as a real number. So that's why we need these conditions. All right, so in this case, we denote the square root by either this thing or this thing. And this thing is called the principal square root. Principal square root of a. Again, watch that square root video to understand these things in detail, okay? All right. Next, we will talk about a couple of properties of radicals. First one is if you take nth nth root of a to the power n. Then this is always a, right? Here you have to assume that this inside this real number, right? Assume this is real, otherwise we can't define this. Okay, so we are assuming the inside thing is real. If you take the nth power of this radical, then it's going to be the radicand a. Let's talk about some examples. If you take square root 3, it is real, right? And square, then this is going to be 3 again. If you take third root 8 cube, then this is going to be 8. However, can you use this property for this square root -9 square? Can you use this property and say it is -9? Not at all, right? Because why? This is not real. So in that case, we can't define this number, okay? All right. So cannot define, let's say. All right. Second property. If a is greater than or equal to 0, right, positive or 0, then a n power, first we take the nth power of a and then we take the square root, not square root, nth root. See the difference? Here we first take nth root and then we take the power. Here we take the power of a and then take the nth root. They are different, right? Because as you see now, now if a is greater than or equal to 0, this is exactly a, doesn't matter. However, if a is negative, we can't define in this way. We have a completely different definition, and I will explain it in the next property. Now, for now, let's consider an example for this case. Now, a has to be greater than or equal to 0. So, if I take 4 square and then square root, then this is same as 4, right? However, if I take this thing, -2 square root, then can we say that it is -2? No, not at all, right? Not at all, because here this case is only for a is positive or 0. However, here a is -2, it is a negative number. So we can't use this property and we can't define it in this way. All right, now let's see how to define this type of numbers. Here I explain the next property. Now if a is negative, again we have to consider two cases. First one, n odd. Second one, n even. If n is odd, then this is going to be a again, right? If n is odd, it doesn't matter if you have a negative radicand or not, right? So it is always a. So example, then now a should be negative and n should be odd. So let's take third power of -8 cube. Now this is same as -8. Okay. All right. Now in even case, this is very important. Nth root of an is going to be not a, it is absolute a. Absolute a. All right. So example, we need negative a and even n. So let's take this thing, the previous, the exactly same thing, right? Okay, so then this is what? It should be absolute value of -2. This is same as +2. Okay, so that's why I said we can't use this second property for this one. Now we can use the third property. So it's going to be positive 2, not negative 2. Again, I'm also discussing this in detail in my square root video. Please search that. Okay. All right. So these are the three properties we just talked about. Now let's recap those. So if you are taking a real radical nth root of in any number, doesn't matter. No, sorry. Not nth root of any number. It should be real, right? If a is negative, it's not real. As long as the radical is real, if you take the same power, right, nth power of that, then it's going to be a. Now, if a is greater than or equal to 0, then if you take the nth power first and then take the nth root, then it's going to be again a. However, in negative case, we have to consider two cases, odd and even. In odd case, it's going to be a. However, in even case, it's going to be absolute value of a. So remember those properties, okay? All right. Now, next we'll quickly go over a couple of laws. Now, in exponents, we had a couple of laws, and similarly, we have a few laws here also. Okay, laws. Again, in this case, we assume all radicals are real, right? Assume all radicals we are explaining here are real. Now, the first law is if you are taking nth root of a product, then we can split this as nth root of one number times nth root of the other number. Okay, example, if you take square root 50, if you had to find square root 50, then you can rewrite this as 25 times 2 square root. And according to this law, we can rewrite, or we can split it into this. Now, what is square root 25? It is 5, right? It is not plus or minus 5. It is 5. And square root 2. This is the final answer. Okay, so we can simplify a value using this law. My second law is if you take the nth root of a division or a quotient, then this is again the split. We can again split them into two pieces. Example, let's take third root of 2 divided by 27. Then what is this? If you use this law, this is third root of 2 divided by third root of 27. Now, what is the third root of 27? You know that 3 to the power 3 is 27. So, this should be 3. So, we can simplify this into this. Okay. My last law, now if you have a radical, nth root radical, and then we take the mth root of that number, then this is same as m times nth root of a, right? We can multiply the indexes and take them it as a single index, right? Example, if you have this thing, let's say we have first, I'm sorry about this, if you have 64 third root and then square root of that, we can assume we have 2 here, then this is same as 6th root of 64. Now, what is the sixth root of 64? We know that if you consider 2 to the power 6, what is this? 2 times 2 times 2, another 2 times 2 times 2. What is this? This is 8, and this is 8, and 8 times 8 is 64. So, this is the 2 to the power 6 is exactly 64. So, this is same as 2. Okay, so we can simplify calculations using these laws. Okay, so let's recap the 3 laws. If you have the nth root of a product, then we can split this as 2 radicals. And similarly for quotient. And if you have 2 radicals, radical inside of a radical, right, then we can multiply the indexes together and take it as single radical of the radicand. All right. Okay, so we talked about a lot of things regarding radicals today, right? So we understood the definition, and we learned some terms, the names, and then we talked about the definitions, 3 cases, then properties, 3 properties, and 3 laws. Okay. All right, that's it. And maybe we can go back to our question we had at the beginning and we can answer them. What is the answer for the first one? It is 2, positive 2. We can define it. How about the second one? Can we define it? No, it's not real because it is the second root or the square root of a negative number. We can't define it as a real number. And how about the third one? Is it negative 2 or positive 2? It is positive 2. It is positive 2 because it is going to be the absolute value of negative 2, which is positive 2. Okay, so we now can find radicals. We know the definitions, we know the cases, negative radicands, even indexes, odd indexes, we know all the cases, so we can find values of these numbers. All right, so I think you enjoyed this video. Please subscribe to my channel if you haven't done already. Please press the bell icon next to it and like the video if you enjoyed and share it with your friends. Okay, so I will bring the next part of I will discuss the next part of this series in the next video. So please stay tuned. Have a nice day.